Hello everyone, you are welcome to clip 1 of part 7 where we review some of wide area network technologies, and actually most of this part will be related to cellular network starting from JSM up to the 5th generation. So um, in part 7 outlines we will review concepts of cellular networks, 3GPP standard and network evolution, JSM network structure and operation, third G, the third generation, mainly the UMTS mobile network. We will talk about opportunistic scheduling, the 4G mobile networks, mainly the LTE and LTE advanced. We will also mention about small cells and relays, and also we review the fifth generation of mobile networks, the need for this new generation, and we will talk about the new radio in the fifth generation and also the network elements. And finally, we will give some of the standalone wide area network standards or technologies. The learning outcome: after watching the recorded clips of this part, attending the online sessions, and performing the quizzes successfully, you will be aware of explain or you will be able to explain the concepts of cellular networks and their structure as well as operations. Be aware of the 3GPP standard and its rules in cellular networks. Be aware of the differences between most mobile network generations, like what are the differences between GSM, 3G, LTE advanced, and 5G. You will be aware of their performance and the quality of service levels. Be aware of several advanced technologies used in to enhance the performance of cellular networks, like small cells, like opportunistic scheduling, like MIMO technologies, and so on. Be aware of the standalone WAN, like long range WAN technology. Okay, cellular network. As we know that the aim or the major requirement of mobile networks is to offer service to customers whenever and wherever the customers are located. This, of course, requires the provision of radio spectrum over the geographical area to be covered. Terrestrial mobile system aim to achieve this target by providing a network of radio stations. This is called spatial division multiple access. Such systems are termed, at least in the old names, like public land mobile network. The cellular network evolutions or evaluations, actually evolutions, the cellular network evolutions are governed by the 3GPP standard, as we will see in more details later. Okay, now let us start with the concept of cellular network. The concept of a cellular network that it consists of mainly four major parts. It is called the radio access network, and you can see this is the radio access network is working actually as the hub of the mobile networks. And then this radio access network, which has the responsibility to be contact or to connect user equipment, which means simply mobile phones or modems or whatever, to the radio access network, and this is through wireless channels. Then the radio access network is connected to the what is known as core network. The core network makes the operations, the major operations of networking, and also it has gateways to connect to the external life or external like world, that the internet, for example, and another public land mobile network, or a public station or public switching network, and so on. And then we have the operation and management, which will just like monitor the whole operations and also taking care of security like operations inside the network. So this is generally about the contents of most cellular networks. It should be like those four items there: the radio access network, the core network, operation and management. This is in the network side, and also, of course, the user equipment or the mobile phones. Okay, so the 3GBB standard, actually, it is called third generation partnership project. This project unites 7 international telecommunication standard development organization. So the major aim is to provide their members with a stable environment to produce the reports and specifications that define 3GBB technologies. So starting actually from the JSM and all the evolution or revolutions in in the mobile networks, it was governed by this 3GBB standard. So they put the standard, they put the specifications, and also they actually look always forward. So for example, right now they're even the standard themselves, they are developed and evolved for the 5G and also for the 4G. For example, some specifications are clarified, or some, if there's some like mistakes or some improvement, they are added all the time. But in the same time, there are groups working for the 6G now. So all the time 3GBB is looking in advance before the technology comes. So there are three technical specifications groups in this 3GBB. So it is called radio access network, and service and systems aspects, and core network and terminals. So the production of this 3GBB standard are published in forms of releases. We call that releases, like 99. Actually, 99 means that it was released in 1999. Then we have release 4, release 5, release 6, and now we are in release 17, and maybe release 18 is already there. I'm not sure, but at least release 17 is already done. So every release, actually, you can see, for example, fifth generation, it starts, for example, they say that starts from release 15, for example. Okay, so all the time, every release, they add, they develop, they clarify. So all the time, there's development and evolution in the standard. All companies, of course, look to these standards, and they try to, or they should be compatible with the standards. So we all the time we have highest compatibility between different vendors and different manufacturers. So the working of those releases are actually, as I said, in parallel. So starting future work will in advance of the completion of the current release. So even, as I said, now they are still working for the fifth generation, but they are already starting the discussions about how 5G, 6G will be, and how it what what are the specifications and what are the requirements for the 6G. Backward compatibility is one major objective of 3GBB. So this is very important that, for example, if you have mobile phone produced like in 10 years ago, so it is still possible to work in even in a new like network element. So all the time they take the backward compatibility. So that this is one of the aims or the objectives of the GBB. So they don't want users that just to change their mobile phones every new standard or every new release or every new development of the networks coming. However, of course, if you want to get the new benefits, of course, you have to have new device which like uh, include that new technology. For example, if you want to use, um, let's say, 5G network, of course, the mobile phone should also contain 5G modem. However, if you have mobile phone with only JSM, it should be possible also to work in the network under the JSM standard. Those are the 3GPP standard generations. So we have the first generation. Of course, first generation, it was not part of the 3GPP, by the way. So it was analog technology, and it was around 1981. But then we have the second G, the second generation. The second generation is the first digital mobile system, which is introduced around 1990. And the main target, or the main objective, is to provide voice and messages over that standard. So the main objective of that standard is to connect people over voice communication and messages. Even the message actually came a little bit late, but the main objective, it was in the beginning, is voice communication. The primary 2G technology was in the beginning the JSM, and after that they include the packet switching for the internet application and data communication, and then they include the GPRS and edge technology, and also we have CDMA1. It was mainly in US and some geographical areas, but JSM was like more an international standard. Then we have the 3G. So the 3G is arrived around 1999, okay, and it was designed for wide band high speed data communication, and we have also different standards. One of these which adopted in Europe is Universal Mobile Telecommunication System, UMTS, with wide band CDMA, and later it was developed this high speed packet data access to support higher data rate. Then we have the 4G, the fourth generation, which was the first mobile network designed mainly for high definition multimedia streaming. So it was the aim here to provide high data rate, which can support like high quality video, for example. And it was defined as LTE and LTE advanced. Okay, and actually, LTE Advanced is the first true 4G technology to be specified by 3GPP, and it started from release 15. Then we have the new generation is 5G. 5G brings another major technology step with the creation of the new radio, which can support intensive number of machine type communication. It is known as, for example, IoT, and also it can support very high data rate up to like 20 gigabit per second in the downlink per cell. So this actually started from release 15 in the 3GPP. And now there's a lot of discussion about the 6G and what it will be. Okay, so actually, if you go to the 3GPP standard, you can find all these releases and available. So this is the website. So it is 3gbp.org. So if you go there, you can find more about those releases and more explanations about each standard. So you can see that this is starting. This is the 3GPP project. Starts from 2G, and now They are going for the fifth generation and go further for the 6G. If we look to the evolution, how in terms, for example, on data bit rate, so you can see here, for example, in the JSM 1991, it was possible to support up to 9.6 kilobit per second only. But with introducing in 2000 GPRS, so the downlink means from the base station to the mobile phone, uplink from the mobile phone to the base station. So in the uplink, it was up to 14 kilobit per second, and in the downlink was up to 40 kilobit per second. So in 2003, so the data rate in the uplink has been about 10 times 140 kilobit per second, and the downlink is about 140 also kilobit per second. In 2006, with the enhanced edge, the uplink has been increased to 200 kilobit per second, and the downlink to up to 470 kilobit per second. Okay, so actually, if you look to the introduction to the system of the third generation, this is the third generation. Okay, and this is the fourth generation, and this is the fifth generation. So you can see from 1991 to 2001, about 10 years, about 10 years here. So actually, if you look to the, for example, to the downlink, it was 10 kilobit per second, and now the downlink is 500 kilobit per second. So it means that about 50 times higher. Okay, so from and also about 10 years here, so you can see that 500 kilobit per second has been up to 326 megabit per second. So uh, the increase here is slightly less than 1000 times, so about maybe 800 times from 500 kilobit. It is half megabit per second, and now we have 326 megabit per second, more than about 700 times faster. Okay, and from 10 to 2018, about 8 years, so you can see that from zero point 0.3 giga to 20 giga, which means that about maybe 40 times increase. So actually, and if we compare between the first GSM data rate up to the fifth generation data rate in the downlink, so it was here 10 kilobit per second, and here it is 20 gigabit per second. So 20 gigabit per second is 20, okay, times 10 of the power 6 times 10 of the power 3, because giga is 10 of the power 9. Okay, it means that it is 20,000 mega. Okay, divided by 10 kilobit per second, 10 times the power 3. So we cancel this, and this is 2. So actually, the data rate has been increased 2 million times. The data rate, the download link, from 91 to 2018, around about 20 years. Yeah, so 30 years, yeah, about 30 years. So that the data rate has been increased 2 million times, which is too much. This gives us the how this evolution of mobile networks was have been like developed in very strong way. Okay, so you can see also we have this from the development was from generation to generation, but also it was within the same generation. For example, in the beginning of JSM, the data rate downlink was 500 kilobit per second, but the latest standard, which with high speed packet access plus, it was possible to support up to 42 megabit per second. It is about 80 times within the same generation. So this gives us some impression how the mobile phone was our cellular network was evolved from generation to generation. So 2 million times faster is not small number actually. And by the way, this is not only in the speed, but in all other terms of specifications. For example, the price, the cost, the quality of service, the latency, the delay. There are many other specifications have been improved with time. And for the 6G, they said that it will support more, and it will use, actually it will be based, and it will support both the artificial intelligence and machine learning applications. uh, about also the core network, actually. So the core network evolution, it was moved it was moving from like circuit switching toward internet protocols. So in the beginning, it was very similar to this exchange that we use in the old telephony system. That when we want to connect two users together, for example, user A with user B, then we use what is known as like circuit switching. So the circuit switching, for example, if we have such kind of matrix, okay, and we have connections here, usually they are open, okay, and now if we connect use this one to user B, okay, and also we connect this one to user A, and we want to connect A to B, then I switch on the connection between A and B. Okay, so A is here, so we can connect A, for example, to word, for just to give this example, this is this one and this one, so we can have circuit switching between A and B. So the circuit switching actually means that we have physical connection between user A and user B. In that sense, how many connections we can provide, it will depend on the available circuits. For example, this circuit is not, it is a physical circuit, but it doesn't mean that it is mechanical circuit. It can be, for example, some like logic gate. But however, that we need to have like that many in order to connect users. And once we connect them, together, for example, in the circuit switching, now we are talking that not wireless, but we're talking about the exchange to connect people together, then this circuit will be busy as far as A and B are connected. And then once the call is ended, then it will be released and it can be available for other connection. In wireless communication, like in JSM, as we will see, it is also the same concept. So we have to dedicate some physical channel between A and B. So, for example, we give some channel to A, some channel to B, and also in the core network, we need to connect them together during the whole like voice communication or connection between user A and user B. And once the call is ended, then this connection is released. However, that such kind of circuit switching is not efficient at all. So in from the beginning of 3G, they include also the internet protocol to be part of the core network. But starting from the 4G, we will have what is known as all IP protocol or all IP based connection, and then we get rid of this circuit switching and we move to the internet protocol, which is connectionless based. So once A wants to connect to B, then they use just this address that to B, and all connections or all terminals are connected together, and then that depends on the packet and the routing of the packet to go from connection A to connection B, as we described it in the previous part. And also, of course, in the 5G, it will be completely based on IP solution. So the circuit switching, the old circuit switching structure has been omitted in a new network or the core network structure. JSM. So maybe one may ask why we need to talk about JSM, as we know all that JSM is a quite old standard, and nowadays we have the 5th G. Why we don't start with the 4G, for example? Actually, the reason that we start with the JSM, that JSM is the first complete digital communication system, and it has been deployed and over the whole world. Actually, it has been very successful standard, for it is original designed purpose. So it was designed for voice communication and text messages, and it was very successful in that. Actually, until today, that many of users, they still use JSM, and it has some good specifications as well, as we will talk about them later. Also, actually, studying the JSM network structure gives us some general overview about the cellular network work, how the cellular network working. So when we go to the JSM, so the same concept has been developed more and more in the other networks as well, but we have still many concepts similar. So when we talk about mobile phone, when we talk about SIM card, what SIM card can do, and for example, how to maintain a call inside JSM. So many concepts are similar. So studying the JSM is introduce us to the other networks as well. So studying JSM is important. So let us go to that. So this is actually the structure of the ASM, as you can see. Uh, uh, as we mentioned before, that in mobile networks we have four classes. So for paths, so we have the mobile station. This is but mobile station. And if you remember, we said that we have radio access network, or radio access path. Here in JSM, it is in the standard of JSM, it is called BSS. BSS means that base station subsystem. Base station subsystem. The base station subsystem consists of base stations or base transceivers. In JSM standard, we call them base transceivers. This is on the tower, as you can see them, or over the building, and so on, which contains the antennas, and it can make the coding, decoding, modulation, demodulation, encryption, decryption, equalization, all the radio functions that can be done in the base stations. So this base substation actually consists of two items mainly: the base transceivers and the base station controller. So the base station controller, it takes care, for example, of the handover process when the user move from base station to base station, or even from area to area. So the base station controller can be involved in such control. So by its name, base station controller. So it takes control of the operation of those base stations. Remember that the base substation is the hub, the radio hub of the mobile network, which is connecting with the mobile station. Okay, so this is very important to remember. So this is the base substation, or the radio access network. Radio access network, as named in new generations, but it is the same concept here. Okay, so usually the base substation is communicating with the mobile station with air interface. So it is called air interface. Sometimes it's called So the downlink is from the base station to the mobile station, and from a mobile phone or mobile station to the base station is called uplink. Okay, the mobile station consists of two paths. One path related to the communication to the mobile network, other path is not related to that. For example, if you have, let's say, calendar or a reader or whatever, so it is not connected to the it is something for camera, for example, for your own use, but this and some part related to the radio access. And this part, which is like dependent on the user, we have it as the SIM card. We call that SIM card. SIM card means that subscriber identity module, and this subscriber identity module, it contains some fixed numbers there or the values, and also it has some dynamic values. For example, it has the pin code, like personal identity number, for example, the pin code. It has a buck code, which is means that it is pin and lock key. And we have the ki actually is very very important for the security application for the mobile station. So your ki, or your security key is saved in your SIM card. Okay, so it is fixed. And also it has the international mobile subscriber number. It is also in the SIM card. Okay, and also it has some values in the SIM card which are like dynamic, changing with time. Like for example, the temporary mobile subscriber identity. When you are like requesting service from the mobile network, they generate some temporary number for you. This temporary number, actually they don't use your own number, because the area to keep this mobile or this call like invisible in the network. So they use some temporary mobile subscriber identity that it can be used during your call, for example, or during the connection between your mobile phone to the network to update some information. After that, this temporary mobile subscriber identity might be changed with time. So every time, every connection, they might give you like new temporary mobile subscriber identity to conceal the mobile phone from the network, from the upper layers in the network. And also we have the location identity, like the location identity. Okay, so the location identity is for example, when you enter a new location, so this location identity is updated in your SIM card. Okay, so those are related to your mobile phone. That we have also the mobile, the identity of the mobile equipment. So international mobile equipment identity is a special code that we all know that we can check that number. If you make that star plus 06 something like that code, the mobile, then you can read the IMEI in your mobile phone, and you can find it also in the box of your mobile. So you can find this international mobile equipment identity. Actually, this number, actually it is also here in the equipment identity register, to make it that if this mobile is allowed to access the network or not. For example, if you bring mobile with a standard that for CDMA1, and you want to operate it in JSM, it will not work. Why? Because they will check this EIR. They found that the mobile is not able to communicate with it is not the same standard, or there's some difference in the standard, like in frequency or something. Actually, if the mobile using completely different protocol, it will not be able to communicate anyway with the GSM network. But if your mobile, for example, is stolen, and at least theoretically, it is possible to update in EIR that this mobile is stolen, and then it will be banned from entering the network. Yes, and now we have the core network. The core network, this is the core network. Actually, it is called in JSM, it is called NSS. So NSS means network subsystem. Network subsystem is the core network of the JSM mobile phone. Okay, so what the NSS do? Actually, NSS taking care of all the network operation. So this is the base substation or base station subsystem, takes care of delivering the message from the mobile phone over the air interface, and take it to the core network. Core network takes it with this interface. This interface is called A interface. It can be over fiber optic, for example, or it can be over microwave link or whatever. Okay, now the message of this mobile is delivered to the core network. In the core network, the first thing that connected the base substation or the base station controller, which takes the message from the mobile phone to the core network, it goes to the mobile switching center. As I said, previously, that JSM is based on like circuit switching, based on the old system circuit switching. The internet protocol switching, it came later, or the packet switching, it came later, okay, with the GPRS. But now this is this is the conventional, or the basic JSM network, which is based on the mobile switching center. Okay, the mobile switching center is like exchange, like in like public telephony exchange. The only difference that the mobile phone in JSM, the mobile phone or the customer, they can move, not like in the public station like telephony system. Now the mobile phone or the customer, they can move from place to, from area to area. So what we need here, we need to take care about the movement or the mobility of customers. Okay, so how to take care about this? We take care by this database. So we have here visitor location registrar. So the visitor location registers, it takes care of or it updates when a new customer comes inside one of this region. So when the mobile phone comes in this region and it was detected over this base transceiver, for example, and it sends its own information, and then the mobile switching center will first will consult the home location register. What is the home location register? Is another database, contains all information of all customers in that operator. For example, if we have operator X in certain country, okay, and that operator, they have all information of all customers. They have their own SIM card, the information like their names, their the subscription type, all information related to that customer, they are updated in this home location register. Okay, now because in this operator, maybe they are distributed over many cities, and in every city they have many regions and so on. So when you enter one of those regions, then the mobile switching center will consult the VLR that we have this new customer here. The VLR will send the information, we will see the details later, to the home location register, and the home location register will send the required information to the VLR. So the VLR will update itself with the new customer, so they know that this customer or this mobile phone is within this area. Of course, it is not necessary for the visitor location register to know in which base station exactly that user is connected, but at least in the region. In that region, because in that region it might be covered by several base stations, and the user itself, he or she might hand off from one base station to another base station very fast. So maybe within a few minutes can move from one base station to another base station. And in order to minimize the traffic between the base substation and the core, we don't need to every time that the customer move from one base station to another base station to inform the VLR about this information. But it is enough for the VLR to know where is in general the user is. So this user is, or this customer might be between like region contains, let's say, 10 or 7 or something of base stations. Okay, and you can see this is the mobile switching center, and this mobile switching center is connected to another mobile switching center. It's called gateway mobile switching center, which can take the message outside this public mobile network. For example, it can take them to the public service telephony network, for example, or to another public land mobile networks. And this is actually the general contents of the core network. So in the core network, just remember this, we have mainly three items, as you can see: the mobile switching center, which is the very important one, and the home location register, which contains all information. It is just a database, contains all information of customers belongs to that operator. And the visitor location register, for every mobile switching center we have it is on visitor location register connected to it. So you can see that we have here another mobile switching center connected to it is visitor location registrar. Okay, and finally we have the fourth part, which is called the operation and management. Here in base in the JSM we call it like operation subsystem. operation subsystem. The operation subsystem consists of three items: the operation and management center, and the authentication center, and the equipment identity register. For the operation mobile center, the operation and management center, actually it takes care about the operation process of this network. For example, it monitor the network. If there is any fault, it makes like generating this the fault type. If there is like drop in the some channels, they will try to allocate it and make like alarm to fix it. So it works the operation and management of the whole network. And also the authentication center, it takes care mainly about security issues. So the security of the mobile phone when they want to connect or they want to make like a call or something. So all the time it is like governed by this authentication center. So the authentication center takes care about mainly two things. First, to make the encryption and decryption, so we protect the message. And second, like conceal the mobile, the user of the mobile or the mobile itself. So when there is a call, then ideally they shouldn't be able anyone to follow or to track that call. So because this mobile is like the user is also hidden by this temporary mobile subscriber identity. So the mobile itself, it should be or the user should be hidden. Of course, this is not real. I mean, the vendors of such system, they give or they sell some equipment that you can like track the users, unfortunately. But at least it needs some like by government or by some authority that they are able to track. However, in the system itself, that it shouldn't be possible to protect the identity of the user of that mobile. So protecting the message and protecting the identity. Those are the two things that the authentication center should take care about. And for the equipment identity register, it takes that the whole mobile phones register, like the IMEI numbers, they are like updated in that EIR. So this is actually generally the contents of the mobile phone or the mobile network, the JSM mobile networks, the base station, and the base station controller, and the message is delivered to the core network. The core network consists of the mobile switching center connected to the visitor location register, and then we have all the information in the general database called home location register, and this part is called the network substation. And yeah network substation subsystem, sorry, the network subsystem, and then we have the operation subsystem as well. So this is actually the JSM architecture. It is very easy, as you can see. It is very like logical, and it makes sense that these contents. However, of course, we will see later when they include also the packet switching inside this architecture to support data communication beside voice communication. Okay, but remember that this one was mainly to support voice communication. Because of that, even the ABIS, the interfaces or the interface between the base station to the base station controller, are based on BCM. So they are based on 64 kilobit per second data, because the data communication, the voice communication, is 64 kilobit per second. But in JSM, actually, we use some linear predictive code to reduce or to compress this up to 13 kilobit per second. So we can have like more than one voice channel per BCM code, 64 kilobit per second. And also this A interface is about 2 megabit per second, which consists also of many 64 kilobits per second bases. Okay, so the main motivation for the JSM is to support voice communication. We will see more about this later, but anyhow, please read the slides, because more information are given in the slides when we talk about the every item in that network, what what it does, and it is operation. So it is important that you read them. So please read the slides carefully. Okay. Yes. Okay. You can see more about these. Air interface. Yes, this is the air interface part. So the air interface part, it is based on time division multiplexing and the frequency division multiplexing, but it is already 45 minutes now. So we stop here and we complete in the coming clip. Thank you very much.